Hello, my name is Elvin Ebby, and I'm a senior at Columbus High School. My AP research project is artificial intelligence's efficacy in general animal classification. So, for some context, which type of artificial intelligence identifies images? Like the name suggests, it is called image identification. So, there are three main types of image identification. Firstly, there's high volume image identification, which is 1 million to 100,000 images of training data. Next, there's middle volume image identification, which is 90,000 to 10,000 images of training data. Lastly, there's low volume image identification, which is 10,000 to 100 images of training data. So what are some uses of image identification? Industries such as public security and surveillance will be using image identification in the present and in the future. For example, China's social credit system uses an image identification system to deem who is a good citizen and a bad citizen. Airports have also started using facial recognition to track whether people have overstayed their visa or if there are potential flight threats boarding a plane. Self-driving cars such as Teslas utilize a form of image identification that tracks and recognizes various images of roads and uses these images to make a safe route to travel. Another use of image recognition is by search engines who utilize image content searches to let people search for their results by inputting images. Lastly, image recognition is used to identify endangered animals so the ecologists can protect their habitats and make sure they don't go extinct. The various uses of image identification and its rapidly growing popularity in the modern world, it is clear that the field of image identification needs to be researched more. Next, we can look at the literature review. Three main foundational documents were used to establish context and the gap in the research. The three documents were Demographic Estimation from Face Images by Anil KJN, Monitoring of Endangered Fish Using Image Processing and AI Tools by TM Plabone, and Deep Learning-Based Image Data Processing and Archival System for Object Detection of Endangered Species by DK Kim. The demographic estimation for face images used artificial intelligence to identify factors such as age, gender, and race in individuals. In the study, machines were given datasets ranging from 1,000 to 1 million images. Lastly, machine results were compared to human results. It was determined that machine results were more accurate in demographic estimation. This study used image identification to test the efficacy of artificial intelligence in identifying various endangered fish species. In the study, machines were asked to identify different endangered fish in varying light conditions. This study used image identification AI to collect images of endangered species, process the data, and identify different endangered species in the wild. The study concluded that image identification AI had an accurate recall rate of 93% and a processing speed of 13 frames per second. From the foundational documents, it is clear that endangered species and demographic estimation are well-researched branches of image identification. General animal classification, however, has little research done on it. To fill this gap in general classification, the study will determine how different machine learning models compare when it comes to general animal classification. So, my research question is, which machine learning model has the most efficacy when identifying general animals? Next is my methodology. First, Amazon Recognition was chosen because of its inbuilt database of 1 million images of animals and because it would be representative of high volume image identification. Next, Always AI was chosen because of its inbuilt database of animals that consists of approximately 10,000 animals and its being representative of middle volume image identification. Lastly, Sense AI was chosen because of its ability to change training datasets as well as create custom datasets to train AI. Specifically, in this instance, Sense AI was given 500 animal images to be representative of low volume image identification. To specify the meaning of general animals, the five major animal kingdoms were used: amphibians, birds, fish, mammals, and reptiles. To test the effectiveness of each of three artificial intelligence systems, 100 images were uploaded into the image identification systems of Amazon Recognition, Always AI, and Sense AI. This 100 image set had 20 images of each type of animal from each major kingdom. These randomly selected images were chosen from a set of 1,000 images of different amphibians, birds, fish, mammals, and reptiles respectively. Each image in these 1,000 sets were assigned a number from 1 to 1,000, and using a random number generator, 100 of these 1,000 images were selected to determine the effectiveness of each artificial intelligence system. To test the effectiveness of artificial intelligence system, each one of the 100 selected images were uploaded onto the artificial intelligence system. After each image was uploaded, the artificial intelligence system attempted to identify each image. Next, the accuracy of each artificial image identification was recorded in a Google Sheets spreadsheet. The spreadsheet had 3 columns for 3 different AIs and 100 rows for each selected 100 images. If the artificial intelligence system correctly identified the image, then its column it would receive a 1. The artificial intelligence system incorrectly identified the animal image, then it would receive a 0 in its column. Lastly, the efficiency of image identification models were analyzed by dividing accuracy by training datasets numbers. Next is findings and analysis. From the graph on the left, we can see Amazon Rekognition had an accuracy of 80% when identifying fish, while Always AI and Sense AI had accuracy percentages around 60%, with Always AI a little higher. From the graph on the right, we can see that Always AI had an accuracy of 85% when identifying amphibians, while Amazon Rekognition and Sense AI had lower accuracy percentages at 80% and 65% respectively. From the graph on the left, we can see Amazon Rekognition had an accuracy of 95% when identifying reptiles, while Always AI and Sense AI had accuracy percentages around 60%, with Always AI edging Sense AI a little bit. From the graph on the right, we can see Amazon Rekognition had an overall accuracy of 86% when identifying the animals in general, while Always AI and Sense AI had lower accuracy percentages at 72% and 61% respectively. The Amazon Rekognition model performed the best in all categories except the amphibian category. Always AI was the next best performing model and was closely behind Amazon Rekognition accuracy percentages in all categories, while also performing better than Rekognition in the amphibian category. Lastly, it can be seen that Sense AI performed the lowest accuracy-wise in all 3 categories and overall as well. To find the most efficient model, however, each model's accuracy percentage per training data image was calculated. Looking at the graph, you can see that Sense AI had the highest accuracy percentage per training data image at 1.22, while Amazon Rekognition had the lowest accuracy percentage per training data image at 0.0086. Always AI had the second highest accuracy percentage per training data image at 0.72. Overall, it can be seen that even though Amazon Rekognition was the most accurate model at identifying general animals, it was not the most efficient. From the efficiency analysis, it can be seen that the most efficient image identification model was Sense AI, while Amazon Rekognition was the least efficient. This discrepancy inefficiency is caused by the large number of training images used by Amazon Rekognition. Also, using the efficiency analysis, an inverse correlation relationship can be seen between accuracy and efficiency. Sense AI's greater efficiency is a significant finding because it has various implications in the fields of AI object detection and image identification. For example, a more efficient method of image identification can lead to less ecological impact. This is because more efficiency leads to less processing power used by computers, and less processing power leads to less energy consumption by computers. Next, the concept of diminishing returns can be seen from this study because it shows that a large input of training data did not lead to a proportional increase in accuracy and efficiency. Even though I use the most representative models of low, middle, and high volume image identification, they are still representative models and cannot truly be used to make a definitive, broad, and general claim and conclusion. Even though the definitive conclusions cannot be made, the findings are still significant and need to be explored further. Another limitation was its limited sample size of the images. Even though 100 images is a relatively large amount of images, a larger sample size would result in more definitive and more accurate results. The limited sample size was a result of a limited time of the project. Lastly, another limitation would be some images in the sample set being defective. There are 3 images that all 3 models could not identify. After examining the images properly, again after the data collection process, no clear difference was found in image quality nor visibility of the animal in the images compared to other tested photos. One similarity, however, between the images that could not be identified by all 3 models was the background of these images were slightly similar to the color of the animal itself in the image. Because image recognition and identification is a broad field with many directions to branch, there are various possibilities for future research. One clear future direction for this study is to take a larger sample size, for example, 10,000 or 100,000 images of animals. Another direction of research could be to increase the animal types, as well as include more exotic animals to see if the AI could actually identify those. Another direction of future research would be to see if there's a similar trend in accuracy and efficiency in road identification. Similar results are seen for different types of roads infrastructure can lead to significant improvements in efficiency image identification and image detection algorithms, specifically for self-driving cars. Lastly, we can test the differences in accuracy and efficiency using low, middle, and high volume to see if a similar trend can be seen in facial recognition as well. Thank you. My name is Elvin Ebby, and you're watching my AP Research Project.